Yeah, hi everyone. So let's get started. As I told you that today we will be discussing the practice set of loop time complexity. And if you're wondering that where you can find the PDF, then you can find the PDF in the comment. Okay, I will put in the pinned comment. Cool. So let's get started. So if you watch the videos, then you might know that that this is the basic, you can say the crux or the complete summary of the loop time complexities, which is that if you're increasing by anything, then it will be order of n, right? So which means, can anyone tell me the exact time complexity if you're increasing by c? So which means let's suppose if I start from 1 and I say I less than equal to n and I plus equal to c, something like that, then what is the exact number of iteration that it will run? Yes, it will run n by c. Yes, that is correct. And if you are multiplying, then exact, can anyone tell me? It is log base 2, right? Base 2n. And this is log base 2 log base 2n, right? Log n. I think this is the summary. Okay, cool. Now let's get started. So let's see this first question, which is quite easy question. I hope every one of you were able to do it. Now they are saying that here I square is less than n and j square is less than n. Now these two loops are very much independent, right? Independent in the sense that first loop and the second loop are not having the I mean any relation. So basically the first loop is of n, the second loop is also of n, and this loop, the inner loop, is not using I. So basically this will run how many times? This is basically, you can say I square less than n, which is I less than, sorry, I square less than n, which is I less than square root of n, right? Yeah, root of n. So this is I square less than n, which means I less than square root of n. And this is j square less than n, which means j less than root of n. So both are running root of n times. So root of n into root of n. So I think order of n should be the answer, right? So theta of n is the answer. Now, can I say order of n is also the answer, since we have seen the asymptotic time complexity videos? Now I will put one more practice set that will be just related to order, theta, and these things, right? This is loop time complexity. So there are two topics that we have covered here. One is loop time complexity and another one is asymptotic time. I mean asymptotic notations like order, theta. So actually I have already prepared those questions. I just need to format in the sense like question number 1 like that. Okay, that's all. So I already have very nice practice set for you. So now tell me, if you are having theta as an answer, now can you also have order of n as also answer? The answer is yes, right? If theta is possible, if theta of n is possible, then order of n is also possible, and big omega is also possible. Okay, cool. Yes. So C is the answer here because root n into root n is actually the n. Now let's see some more interesting questions. What will be the time complexity of the following nested loop? That's being asked. Okay, tell me how many times you are going to run this loop. So let me go to the next page to solve this question, right? Now, tell me how many times you are going to run this loop, the uppermost loop. So you are dividing by 2. Every time you are dividing by 2, which means that I think you are going to run it log n times, right? Log base 2. So I hope that is fine. Here you are multiplying by 2, again log n times. Here you are adding by 2, which means n by 2 times, right? So what is the answer? Since this is just constant number of operations, so let's just ignore it. So log n multiplied by log n multiplied by n by 2, which is order of n. So what is the answer? N log n square, right? Now tell me, is this theta, big O, big omega? What kind of notation I should be using here? What is the strongest one? Strongest one means agar strongest always mean that if you, I mean strongest का मतलब क्या होता है? It means कि अगर वो पता है तो बाकी के तो derived हैं. I mean everything else can be derived, right? So that is the strongest one. So strongest is theta, right? I mean, if you know the theta is there, then obviously you know by implication you know that order O is there and big omega is also there, right? So you can say that you can put theta here. So I think this is the strongest one. Okay. Now let's see this. What will the time complexity of the following nested loop? Okay. So this is one loop. Here you are having two nested loops. So tell me that, I mean, how many times you are going to run this? This is going to run, I think, log n times, right? Yeah, this is going to run log n times. So just a second, let me just remove this. So this is going to run log n times. This is plus equal to 2, I think n by 2 times. This is, yeah, this is interesting. Can anyone tell me this? Yes, this is log n time, right? Log n times. So we have already done this in the video. So let me just quickly repeat you that, see, if you're going to have the exponent, I mean exponentiation, which means I square, then log n, a multiplication, then log n, and if it is plus, then it is n by c or something like that, right? Okay. So it is, what is the answer here? It is log n multiplied by n by 2 plus log n. Is this correct? Or there is any issue here? Have you understood this? See, this is log n, and here you are having two loops. So you need to plus it. Don't multiply it. Okay. Don't do this mistake. Don't multiply. You need to plus it. So if you're doing the plus, then final asymptotically, you can say it is n log n. Right? Yeah, n log n is the correct answer here. What will the time complexity of the following nested loop? This is, yeah, tell me. First, you tell me your answer, and then I will solve it. Okay. Log of n factorial. Okay, let's just see how last step, how it is n log n here, because it is n log n. I mean, you can just ignore this log n, because asymptotically this n is higher, right? Since n is higher, I always talk about I mean, I'm always talking about asymptotically here in these questions. Okay, since n is having the higher growth, that is why you can ignore this log n. I mean, like with respect to this n. Okay. Or okay, let's not complicate it. I hope you understood. Okay. Now here, let's just see the answer. So this is going to run n time. Now every time you're dividing, but okay. So this is going to run how much time? Can anyone tell me? This inside loop is going to run log of I times, right? Because you're initializing by I, and every time you're dividing. No, log of I, because j value is initially I. So you can say for I equal to 1, it is going to run log of 1 time. For I equal to 2, it is going to run log of 2 times. For I equal to 3, it is going to run log of 3 times, like that. And for I equal to, since I can take, I mean, at max the value of n, log of n times. So if you add all of this up, then what will the answer? Log 1 plus log 2 plus dot 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 log n, right? This is log of, this will be multiplication, right? Because of the log property, 1 into 2 into 3 till n, which is log of n factorial. Okay. So what is log of n factorial? Do you know that log of n factorial is n log n? I think we have covered that. This is strictly equal, right? Yes, this is string, okay, Stirling approximation. Okay, we have covered it, I think, right? So log of n factorial is n log n. And do you know that n power n and n factorial, which one is greater? Which one is greater? N power n. This is strictly greater. What do I mean by strictly greater? Is that n factorial is equal to small o. Okay, this is small o. Small o of n power n. But if you take log, as we have already seen, but if you take log, and if I just ask you log of n power n and log of n factorial, which one is greater? Then they are equal. Yes, that's very nice. Then they are equal, which means that log of n factorial is same exactly equal to this, which means in terms of theta, you can say, then it means n log n. This is nothing but n log n, right? N log n. Okay. Actually, this is one information that I think most of the places, non-standard places, or I can say the coaching institutes or something. So at most of the coaching institutes, that is, I'm not sure, but what is the current situation? But I'm like, to be honest, I have not seen it, seen the current coaching videos. But I think at most of the places, this is being taught wrongly. I mean, they interchangeably use this n power n and n factorial. They just say that n power n and n factorial same. Am I right, or I'm wrong? I mean, they have updated their knowledge, or am I right here? So 3-4 years back, this used to happen. They just interchangeably use this n power n and n factorial. Okay. Okay. Now they have updated. That's cool. So earlier that used to happen. So basically, this n power n is strictly greater than n factorial. Okay. Now some of the places at some of the coaching institute, they just say that they just interchangeably use it, but that's not correct. Okay. So final answer is n log n. I hope that is fine. Okay. Now, what will the time complexity of the following nested loop? Let's just see this. What is your answer? Were you able to solve that question? So this is going to run n time. Okay, that's very interesting. Let's just do one thing. Actually, I will come to this, which means let me just talk about this loop. Okay, for now, I will come to the complete program, but for now, can I just talk about this inner loop? I mean, this outer is okay because I just have to multiply by n, right? Okay, I just have to multiply by n. So this outer for loop is okay. Let me just walk through this inner loop. Okay. Tell me how much time this loop is going to run. You're initializing by I. Every time you're dividing by 3. Log of I times. Right? Okay. I hope you are getting it. Let me just go to the next page and try to explain you. See, let's just talk about this particular program. Now, this inside loop is going to run log of I times because you are initializing by I and you are dividing by 3. That is fine, I think. Now, can you tell me this loop, how much time this is going to run? This is log of n time, right? This is log of n time. Now, I can say that, okay, this is log of n time, this is log of I time. And let me do one calculation, which is actually, which will be little wrong, but still I'm just doing it. So log of n, this is log of I, right? Now I can say that, okay, for I equal to 1, this is inner loop is going to run log of 1 time. For I equal to 2, inner loop is going to run log of 2 times. For I equal to 3, inner loop is going to run log of 3 times. Since, and, okay. And let's suppose for I equal to, actually this calculation is wrong. Can anyone tell me where is the, I'm intentionally doing wrong, but I'm failing at it. Yeah. So I'm not able to do wrong here. So basically for I equal to 1, the inner loop will run log of 1 time. But I will never be 2. This is the case. Okay. So don't do this mistake. I will be, next time I will be 3. Right. This is going to run log of 3 times. And next time I will be 3 square. This is going to run log of 3 square time. Next time I will be n. Let's suppose this is 3 power k, which is, let's suppose, n. Then this is going to run log 3 power k time. Then you need to add all of this, right? Okay. So this will be, I think I have done it, right? So if you add all of this, then this will be multiplication. And if you multiply this 1 into 3 power k, this will be 3 power. You are going to sum all of these powers, and these powers are just, you can say this is just order of k square. So instead of writing the exact thing, I am just writing order of k square. K square is outside. K means k is actually log n, right? Is this clear to everyone? Why k is log n? Because I assume that 3 power k is n. So that's why k is log n. So basically it is log n square. So you can say that this inner loop, okay, this inner loop that you're talking about, this loop is going to run log n square times. And then what is the final answer? The outer loop is going to run n times. I mean, for k equal to 1, I mean, these are independent actually, right? So since these are independent, you don't need to worry about it. So basically it is n into log n square times, right? N into log n square. I think it was a good question. Were you able to solve that using the practice set earlier without seeing the solution? Okay, Satyam is saying yes. Shri, what about you? Karthik, Twinkle, you people were able to solve it? Okay. Okay, had to take hint. Okay, no problem. So I hope that is clear. Yeah, that was a good question, I think. Now let's see some more good questions. Now they're saying this is going to run n square times, I think, right? This is going to run n square times. Okay. And this is going to run I time. So you can say that, okay, let's suppose this is going to run k times. Instead of n square, I will put k n square later, but you are going to run it k 1 time plus 2 time plus 3 times till k time, and which is k square, which is n power 4. I hope that is fine. So n power 4 easy enough, right? Okay. ये समझ आ गया? Question 6 is clear to everyone, or there is some confusion? Please let me know. Okay. See, this loop is going to run n square times. Let's say this is k. I mean, instead of saying n square, let's say this is k. So the inner loop for I equal to 1, I mean, I'm saying that the outer loop is going to run k times. Okay. So for I equal to 1, inner loop will run 1 time. For I equal to 2, inner loop will run 2 times. For I equal to 3, inner loop will run 3 times. And for I equal to n square or I equal to k currently, inner loop will run k times. So you just add all of this, it will be k square, right? K square means n power 4. Okay, because k, I just took it n square. Okay. Now let's see this. What will the time complexity of the following nested loop? This is going to run n time, n square time, and here, yeah, that's interesting. So what is the answer here? I think this is also going to run n square time, right? Okay, instead of n square, let's take it k. So this is going to run k time. Okay, let's just focus on this loop only. Okay, let's just, I mean, later I will multiply by n. So this is going to run k time. So this inner loop, okay, for j equal to 0, it will run 0 time. Okay, for j equal to 1. Okay, so for j equal to 1, it is going to run 1 time. पहले जैसा ही है क्या? हाँ, this is same, right? So n power 4 तो इसका हो गया. N power 4 is this, and then you multiply by n, right? So this is n power 5. 1 time j equal to 2 के लिए ये k की जगह और कुछ ले लेते हैं. Let's take it. Can you suggest me any other alphabet? X तो नहीं. X is not looking good. Anything else? T, P. हाँ, P is looking good. Yeah. So P time. So j equal to 2 के लिए this is 2. Similarly, for j equal to p, it is going to run p times. So this is p square. So total, this loop will run p square time. P square means p is n square. So this is n power 4, and n ka multiply hoke, this will be n power 5. Okay. Yeah. Actually, in ISC also, when you, I mean, if you get a chance to study in ISC or maybe any other IT, but I'm talking about my experience at ISC. So there was one professor, I think I told in one of the video, his name is Chiru sir. So what used to happen in machine learning class, he used to write all the alphabet. I mean, literally, I mean, alpha, beta, A, B, C. He used to write all of this in one board. And then he used to say, give me an alphabet that is not here. Okay, and then we are also looking, we are saying, okay, S, we can use S. Then we say, okay, S is already there. Then we say, okay, T. Okay, T is already there, like that. So it's just like a puzzle. He used to say, I mean, in almost every class, give me an alphabet which is not on the board. Okay, and then we used to think that, okay, which alphabet is not on the board. Anyway. So n power 5 is the answer. Cool. Now let's see this question. Why we are assuming 1 plus 2 plus this as p square? Okay. No, we are not assuming. It is just a simple formula. K equal to k into k plus 1, I think, right? By 2, which is just in the order of k square. I mean, it is just an order of k square. I mean, it will be whatever it is, k square plus k by 2. You just ignore the constant, okay, and you just ignore this lower growth function. I mean, I'm just talking asymptotically. Yes, we can just assume higher order. Okay. Yes, you can focus on the significant term, definitely. Yeah. But sometimes if it is in the exponent, then you have to be careful actually. I mean, let's suppose this is 2 power k square plus k. At that time, I don't think you can ignore this k, right? Or maybe 2 power n square plus n. Can anyone tell me why we cannot ignore? Because this is 2 power n square into 2 power n. Ignoring this n means you are ignoring 2 power n. Okay. Ignoring this n means you are ignoring 2 power n. You can't ignore 2 power n. 2 power n is huge number. Yes. So अगर वो normal है, मतलब normal case में you can ignore, but normal in the sense normal है, log में भी you can ignore. In log also it doesn't matter because it is just in fact, if you over approximate it, then also it is just n square plus n square, right? If you just do it overly, okay, and then also it is log of 2n square. This is just log of 2 plus log of n square, and you will end up ignoring this. I mean, even if you overly do it, I mean, n को n square भी मान ले, तब भी चलेगा. मतलब in log also you can do it, but exponent when things are little basically, you have to be little careful in case of exponent. Okay. Yes. Yes. Have you seen that video, everyone? Rice grain story of that king and Pandit. So that was a good story, right? Okay. ये हो गया ना, ठीक है. What will the time complexity of the following loop? Okay, this is little tricky. Have you solved this? For I equal to 1, I will be just like this, right? I equal to 3, then I equal to 4, like that. How k values are incrementing? K is initially 1, and then it will be, I mean, I equal to 1, k equal to 1, and then k value will be 3, k value will be 5. So what is the answer you are getting here? This was very good question, I think. What is the answer that you people got? Have everyone solved it without seeing the solution? I think solution is already there, but have you guys solved it? Anyone here who has solved it? Okay. So, I mean, that was, I think, good question. But have you understood the solution? Okay, let's just see what is happening. See, we need to check how many times it is running, right? So how k values are changing? K value will be 1, and then it will be k plus I. Okay, so let's just see that how k values are changing. Okay, let me first observe this. For I equal to 1, k is 1. For I equal to 2, k will be 1 plus 2, right? For I equal to 3, k will be, k is already 1 plus 2, then you need to also add 3, like that. And for I equal to whatever, I mean, I don't know, maybe, मतलब जब तक k n नहीं हो जाता, है ना, मतलब this will run the moment k key becomes n. Let's suppose कि I equal to t पे ये n हो जाता है, okay, और I equal to m पे ये होगा. Is this correct? I mean, at least have you understood that for I equal to 1 k value is this, for I equal to 2 k value is this? At least this particular table is clear to everyone. We will see about the time complexity, but this value or this particular table is okay. Okay. Now let's talk about the number of times it is running. This is n. One Sandeep is saying 1 is less than 1. This is n, okay? This is not I. Okay. Now, if this table is clear, then we will talk about number of times it is running. First, let me know if this table is clear. Okay, let's not worry about this. I mean, this time complexity. Let's not worry about the time complexity. At least let me know if the table is clear. I value will be 1, 2, 3. Let's suppose till m. Okay, I mean m is some random number. We will see that what is this m. But anyway, that is fine. You know, so k value will be incrementing like that. Now let's just assume that for some value of I, it will be n. K value will be n. For some value of I, कभी तो k value n होगी ना, कभी तो that will be n and that will, I mean, that will go out of the loop, right? For some value of I. Okay. Now, if I just ask you that what is the time complexity here, can anyone tell me smartly in terms of m or in terms of n or in terms of anything? कितनी बार ये loop चल रहा है? How many times this loop is running? Yes, exactly. M times. So what is the time complexity? Theta of m, right? This is the answer. But tell me, can I say this is the answer? No, answer should be in terms of n, right? In terms of n. N is the input here. So input size of the input. So if you want to find out this m in terms of n, then you can say this is m square, which is n, then m is square root of n, right? So what is the answer here? Square root of n. Yeah. So theta of m is answer, but I cannot say that in answer in terms of n. That's why I will say instead of theta of m, I will say theta of square root of n. Okay. So let's go from the very beginning. Okay, let's go step by step. First, tell me if this table is clear. For I equal to 1, how it is happening. For I equal to 2, how k is updating. Now, it will run till k becomes n, which means it will run for I equal to 1, for I equal to 2, till I equal to m. It is running m iterations. It will run since till the point k is n. So this loop is going to run till m iterations. So loop will run till m iterations, right? And then in every iteration, I'm just doing constant number of operations, so that doesn't matter. So that is why the time complexity is theta of m. But from here, you can easily find out that m is square root of n, right? I mean, if you find out this is m into m plus 1 by 2 equal to n, तो m को in terms of n भी अगर मतलब मैं quadratic, even if I solve this quadratic, then also it will be m equal to square root of n, कुछ भी आएगा plus minus divide by 2 or something, ठीक है? जो भी है doesn't matter. Basically, it will be in the order of square root of n. Okay, so m is square root of n. So that's why square root of n is the answer. I mean, order is fine, but theta is just a stronger one, right? That's why I'm writing theta. Okay. Is this clear? I think that was a good question, right? Let's see this question. What will the time complexity of the following loop? This is going to run n time. Yeah, that's interesting. See, you are basically adding 2i every time, right? If you're adding 2i every time, if you add c, if you remember from this particular slide, I think if you add c every time, then how many times this loop run? N by c times, right? That's what we have seen, n by c times if you add c. Now, instead of adding c, if you add 2i every time, then how many times it will run? Can anyone tell me how many times this loop is going to run? See, this is n minus I. First of all, the difference between these two, initialization and this is n minus I divided by 2i. N minus I divided by 2i. ये समझ में आया? If it is starting from 1 or starting from 0 or something like that, then it is n divided by 2i. But now currently it is n minus I divided by 2i. Let me know if that is clear. Because this, the difference is n minus 2i, n minus I, and every time I'm adding 2i, so that's why I have to divide 2i. Suppose this is starting from 1. If it is starting from 1, then can anyone tell me exact number of iterations? If it is starting from 1, then n by 2i. Then n by 2i. Okay, because you are adding by 2i, right? If you add by c, you divide by c. If you add by 2i, you divide by 2i. So that is why if you are adding by 2i, you divide by 2i. But since it is starting from I also, that's why you take you take how many, what is the difference? So since you are not going to start from 1, so that's why you are going to say that okay, n minus I is actually number of number of elements, or whatever the distance between these two, initialization and this. So n minus I upon 2i. Okay, which means n upon 2i minus 1 by 2 or whatever, let's just leave it. Okay, n upon 2i side. So basically n upon 2i times you are going to run, which means for I equal to 1, you are going to run n upon 2 times. For I equal to 2, you are going to run n upon 2 square times. For I equal to 3, n upon 2 into 3 times, like that, right? Okay, so let's just see how it is happening. So for I equal to 1, n upon 2, for I equal to n upon 2, 2 into 2, n upon 2 into 3. And now you need to add all of this. So finally, n log n is the answer. I think we discussed this inequality also. Have we discussed this inequality? This is log n in the lectures. I think we discussed, right? Okay. So that is why the n log n is the correct answer here. Now let's just do one thing. Uh, let me just see if you can answer this. Okay. Let's suppose here this is also something else. Maybe let's suppose instead of I plus plus, I'm having something like I into equal to 2. Then what is the answer? See, for I equal to 1, it is going to run n upon 2i, right? N upon 2i means n upon 2 into 1. Now I is not 2. Sorry, I is 2. Currently I is 2. That is okay. But now I is not 3. So I will be 2 square next time. And then it is n upon 2 into 2 square. Now I will be 2 cube. N upon 2 into 2 cube. And now suppose I is 2 power k, which is n. Then n upon 2 into 2 power k. So what is the answer? Can you sum all of this? Let me try summing all of this, right? See, n upon 2 in 2 मैं कॉमन ले लेता हूँ, 1, right, plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube plus 1 by 2 power k. सही है ना? Or there is something I missed? I think this should be right, right? Okay. So okay. Actually, I do not need to calculate this GP. I think in the algorithm I have discussed these things. So if it is decreasing GP, see, let me just tell you one thing. You know, if it is still infinite, let's suppose, see, I need to calculate this, right? मुझे ये 1 upon 2 power k तक calculate करना है. Instead of this, let's suppose if it is still infinite, can you tell me what is the answer? A upon 1 minus r, right? A upon 1 minus r. Everyone know this formula of infinite GP, right? So we talked about these things, in the algorithm, because there we talked more about these complexities and all. But anyway, this is constant basically. Finally, this is constant. Even if it is still infinity, this is constant. That's what I'm trying to make a point. So even if it is still infinity, then also the summation is constant, isn't it? So whatever, ये तो 1 upon 2 power k तक है, तो कम ही होगा. So just ignore this. This is just constant, right? So final answer is n. Final answer is n. Is this okay to everyone, that how we are calculating this n? How we are calculating this summation? Okay. First of all, why we are writing the summation is this okay? How we are writing? See, for I equal to 1, I'm going to run n upon 2i. Okay. Every time it is n upon 2i times. For I equal to 2, it is n upon 2 into 2. But now I want to be 3. I will be 2 square because I am multiplying by 2, right? And then I will be 2 cube. I will be 2 over k at the end, right? Which is, let's suppose, n. Okay. So that's why you need to add all of this. You can take n by 2 common. 1 plus 1 by 2 plus 1 by 2 square plus 1 by 2 cube, like that, plus 1 by 2 power k. So this is the final answer. Now I need to solve this. Okay, we need to solve this. Now what I'm saying, that even this GP is still even infinity. Even this GP is still infinity. Then also, I mean, if it is infinity, then also it is 1 upon 1 minus r. Then also it is just constant. I can calculate. That's not an issue. But I don't want to calculate it. Even if it is still infinity, then also constant. Abhi to pehli ruk gaya na. So it must be even smaller than some constant that is still infinity, right? So it is just constant. I mean, ultimately it will be just constant. So that's why I'm not calculating it. I'm just saying you can just avoid these calculations, which is completely unnecessary, isn't it? So you can avoid this calculation. This is what I'm saying. Whatever the GP summation, you know how to do and all, but let's not do it. That's what I'm saying. See, can you tell me this is decreasing GP or increasing GP? This is decreasing or increasing? Decreasing, right? In case of decreasing GP, you can always approximate this whole thing by first number. Just one example. If it is a decreasing GP, okay, so any decreasing GP, let's suppose n plus n by 2 plus n by 2 square plus, let's suppose, until unless it becomes 1. Is it decreasing or increasing GP? N by 2 power k is, let's suppose, 1. Okay, I mean, this 2 power k is, let's suppose, n. This is decreasing or increasing GP? If it is decreasing GP, then the summation is equal to, I mean, asymptotically, I'm saying, obviously, okay, summation is equal to first term. First term is the second term here. Okay, first term, which is n. Even if you calculate this, you can calculate this. This will be, is this lagging? My voice is lagging or this is fine? Okay, just a second. Hello. Hello. Is this a little better? Okay. We will see if it is lagging again. Okay. Now, what I'm saying, that if it is decreasing GP, then the answer is first term. Okay. If it is increasing GP, on the other hand, let's suppose that there is some increasing GP. Maybe this is, you can say, 1. This is 2. This is 2 square. This is 2 power 3. 2 power k. Tell me, it is increasing GP or decreasing GP? It is increasing, right? Increasing GP. So you can take the last term. Then summation even if you solve this, okay, even if you solve this, it will be something like this, right? If I remember correctly, कुछ तो ऐसा ही होगा ना, 2 power k minus 1 होता है शायद, right? Even if you solve this will be the answer, okay, which is just 2 power k. I mean, asymptotically. So basically, you don't need to solve the GPs. That's what I'm saying. Okay, in these asymptotic calculations, you don't need to solve the GP. If it is increasing GP, if it is decreasing GP, take the first term. If it is increasing GP, take the last term. Okay. So tell me, this is increasing or decreasing? Since this is decreasing GP, take the first term as an approximation. Always it will work correctly. I will prove this in the algorithm. So we are going to prove these things. Don't worry. Okay. In the algorithm, we are going to prove these things. So for now, I hope this is okay. Sorry. Okay. So now the final answer is theta of n. Earlier, what was the answer? N log n. Okay. Yeah, that's interesting. See, if you're increasing by 1, then n log n was answer. But if you're increasing by, I mean, if you're multiplying by 2, then you are actually reducing the factor of log n, right? You're reducing the factor of log n. Then n is the answer. Okay. If you are doing this change, then n is the answer. Is this okay to everyone? Okay. I'm audible, right? Cool. Now let's quickly see this question. Yeah. Was it solvable or there was some issue in this question? Let me know. So they are saying that you run it p times. So after you run, what will the answer of p? P will be log n, isn't it? Just let me know what is the answer you are getting. So if you run through this loop, after this loop, p will be log n. Now you are saying that you always multiply by 2. Then here the answer will be log p. And p is already log n. So log of log n is the correct answer here, right? Log of p. Yeah, I think we are right. Sorry, log n is the answer complete plus log of log n. Okay, which is finally log n only. I mean, they're asking for the time complexity for this program. Okay. Yeah. So that's why log n is the correct answer. What will the time complexity of the following loop? So here we are having we are incrementing by 1, so it is n. This is, yeah, that's interesting. Can anyone tell me the exact number of terms it will run? My voice is breaking a lot. Is this true? Let me know. Okay, let me connect with my mobile hotspot then. Just a second. So let me know if the earlier question was not clear. Okay, so see, I think that was easy one. So you are going to get p equal to log n, right? You are going to get p equal to log n. Now you are going to run this loop log p times, which means since p is log n, then you are going to run this loop log n times. And then what is the final answer? This is log n, this is log n. You need to add both of this. So that's why log n plus log n. And finally, you need to take the significant term, which is log n. Okay. Cool. Now, let's just see this. So how many times this loop is going to run? Can anyone tell me almost, I mean, the exact time? So you can say you are adding j, right? So you need to divide by that. So what is the answer? N minus, I think, 2j divided by j. Is this okay to everyone? N minus 2j divided by j? Okay. So basically, this is going to run n minus n upon j times, right? Minus 2, let's just forget about it. So n by j times, which means if j is 2, then it is going to run n by 2 times. If j is 3, then n by 3 times. Okay. If j is 4, then n by 4 times, like that. Now you need to add all of this, right? N by 2 plus n by 3 plus n by 4 till n by n. If j is n, because at the last j will be n or n minus 1, does not matter. So basically it is n, you can take common. So it is n log n, right? I hope that is fine. Now let's see this question number 12. What is the time complexity of this loop? Tell me. What is the time complexity of this loop that you are getting? So this is n, I think. And this is going to run n by I times. For I equal to 1, I think this is g. For n by 1, n by 2 plus n by 3. For I equal to 1, you are going to run n by 1. For I equal to 2, n by 2 times, like that, right? And then so on. So that's why final answer is n log n, I think, right? Okay. Let's see this question. What will the time complexity of following loop? This is log n times, that is okay. But this is I times. Right? For I equal to 1, for I equal to 1, you are going to run 1 time. For I equal to 2, you are going to run 2 times. For I equal to 3, you are going to run 3 times. For I equal to 2 power k, you are going to run 2 power k times. So, I mean, 2 power k is, let's suppose, n. Okay. Then what is the answer? Sorry, I want to be 3. I want to be 3. Yes, that's a nice observation. So for I equal to 4 or I equal to 2 square, it is 2 square times. For I equal to 2 power cube, it is 2 cube times, right? So you need to add all of this. Now tell me, it is increasing GP or decreasing GP? Since it is increasing GP, you just say 2 power k, which is n, right? Okay. So theta of n is the answer here. Let's see this question. Let me know if earlier question was clear. If it is not clear, then I can just go through it again. But I think that is okay, right? I mean, for I equal to 1 time, 2 time, 2 square times, 2 cube times, right? And then you need to add all of this. Since it is increasing GP, right? Since it is, I can say, increasing GP, take last term. Don't do this GP calculation in asymptotic notations. Okay, we will prove this. We will prove this in the algorithm. I mean, there is nothing fancy to prove, but we will see this in the algorithm. Okay. Let's see this question number 14. Okay. So what is the time complexity of the following loop? This is log n times. This is divided by 2. This is, I think, they are going to run I by 2 times. This is I by 2 times. For I equal to 1, for I equal to 1, this is 1 by 2 times. I mean, it won't run actually. For I equal to 2, oh, I mean, 1 by 2 means it will run 1 time. Anyway, for I equal to 2, this is 2 by 2 times. For I equal to 2 square by 2 times. I equal to 2 cube by 2 comes. I equal to 2 power k, which is, let's suppose, n, 2 power k by n 2 times, right? So again, you can say this is increasing GP. So 1 by 2, you can take common. So if you take 1 by 2 common, then it is just increasing GP, right? This is 2 power k. So 2 power k means this is again going to run n time. Okay. I'm not going to do complete calculation, but I mean, exact number of steps we don't need to find out. But yeah, order of n should be the answer. Okay. Let's see this. Can anyone tell me how much time it is going to run? N cube divided by, sorry, not divide. You are multiplying, right? Yeah, that's interesting. Can anyone tell me how much time this is going to run? Log of n cube, that is correct. But interestingly, it is multiplication by n. So the base also is n. Okay. Which is 3. Just 3 times. Because here the base is also, I mean, the whatever is in the multiplication, that comes as a base. If you're multiplying by 3, then it is log 3 times. Okay. Log base 3 n times. If we are multiplying by n, then it is log base n cube time. Or otherwise you can see that I equal to 1 के लिए चलेगा, फिर n हो जाएगा, n square हो जाएगा, n cube हो जाएगा, उसके बाद it is n power 4. So 3-4 times like that, right? I mean, n cube के लिए भी नहीं चलेगा, तो 1 से 1n square. So just 3 times, because I is in power of n. So anyway, like what can I do? I can just multiply by 3 at the end, which is just constant. So which means either you multiply by 3 at the end, or you just ignore this loop, right? I mean, because I is independent, so you just ignore this loop. You can solve for this inner loop. Okay. So let's just solve for this inner loop, because outer loop is just 3 times. I equal to 1, I equal to n, I equal to n square. That's all. Okay. That outer loop. So that's why let's not worry about the outer loop. So this is the outer loop story. Cool. Now let's do this. This is EG, right? I think this is n by 2 times multiplied by log n times. N by 2. N log n should be the answer, right? So this is n by 2 times, and this is just log n times. So I think n by 2 into log n. Yeah, n log n is the correct answer here. Let's just do this. What is the time complexity of this loop? I is running n cube times, but if I is a multiple of 3, then you are going to break. So I think it will run for, it won't even run one iteration completely, right? I mean, at I equal to 0 only it will break. Uh, Ajay is saying that is it okay to ignore base, log base? Yes, it is okay to ignore log base if it is a normal story. If it is in 2 power or some power, okay. If it is in some power, then you can't ignore. Do you remember there was one question that we did? I think n power log. I don't remember the exact numbers, but n power log 7 or n power log here 2 or something, right? So we did one question, the comparing between these two functions. Do anyone remember something like that? कुछ ऐसा ही था शायद. कुछ तो ऐसा था. I don't remember exactly, but yeah. So anyway, you can ignore bases, but almost all the time until and unless it is in the exponent. If it is in the exponent, then the things are different. Okay. Then here maybe log base 2 n and log base, let's suppose 4n. Okay. Both are different. Both are different. Okay. Both are not same. Both are not same. Which one is, can you tell me which one is greater? If the greater is the log, then this number is lesser. Since this number is lesser, that's why this is greater. Okay, this is greater. The first one is greater. We talked about it. It is strictly greater. Strictly greater means what? That you can even say small o. Okay. N power, you can say n power log 4n is small o. This is small o. Strictly greater means small o. Okay. So you can't always ignore this base. It depends if it is an exponent or not. If it is not an exponent, then you can ignore. Otherwise, you can't ignore. Okay. Okay. So here at I equal to 0 only you are going to break. So it is just a constant time. Okay, constant time. Because at I equal to 0 only you are going to come out of this loop. So Shri is asking that in question 15, if we take j less than I here, if you are going to take j less than I, okay, then it will be little interesting. Do you want me to do it? Okay, let's just do it. Okay, you did it that way. Cool. Maybe this could be a good exercise. If you do it, then it will be I by 2, right? For I equal to 1, you are going to run I by 2 times. For I equal to 1, you are going to run something for I equal to n, and for I equal to n square, right? For I equal to 1, you are going to run one time, or I mean, this will be just one time you're going to run, which means this inner loop for, so you can say this is inner, this is innermost, this is outer, right? Something like that. So you can say that for I equal to 1, this inner loop will run just one time. Innermost, I mean, that's the final answer, right? I mean, summation of all of this will be the final answer. So innermost will be running log n time. For I equal to n, this will be running, inner loop will be running n by 2 times. And that is why the innermost is always running log n times. So finally, I mean, you're running it log n. And then for every iteration, it is running log n time. So it is n by 2 log n basically. N by 2 log n. Okay. I mean, for every inner loop, you're running n log n time. So if we are going to run this n by 2 times, it is n by 2 log n. And here n square by 2 times, then it is log n for one iteration. So n square by 2 log n. So what is the answer? N square log n will be the answer. Okay. Earlier, what was the answer? N log n. Okay. That's interesting. So if you do this less than I, then n square log n is the answer. Yeah. Because here the I value is actually going till n square. Earlier, it is fixed to be n, but now you are making it higher, right? Okay. So n square log n is answer here. This could be a good question. Okay. Actually, like in the gate, they have not asked these many, I mean, tricky questions in the loop time complexity. But if you do this practice, then I hope you will be more comfortable with any other question. Why not till n cube? For I equal to n square, the moment I is n cube, because it is strictly less than n cube, right? The moment I is n cube, it will come out of the loop. Okay. In the next iteration, it will be n cube, then it will come out of the loop. Let's see this. What will the time complexity of the following loop? Ajay is saying it will help in our placement at ISC. Okay. First go to ISC, then you can prepare for placement. don't directly prepare for the placement. So anyway, like these questions, I don't think they will ask in the ISC placement also. I'm not sure. I mean, in ISC, they don't ask these things. They ask some more better things in the life. Okay, cool. So what will the time complexity of this following loop? I mean, these are basics. I mean, this helps anyway. I mean, whatever program you are writing, this always help you to find out the time complexity. So these are the basic things. That's why I'm doing that much practice. This is the log n time, I think. And this is I times. So this will be I times. So for I equal to 1, this will be 1 time. For I equal to 2, this will be 2 times. For I equal to 2 square, 2 square times. Similarly, for I equal to 2 power k, 2 power k times. You just add all of this. What will the answer? 2 power k, because increasing GP. And 2 power k is nothing but n, right? So I think n is the answer here, right? Okay. Yeah, that was the trickiest question, I think. Okay, that was the most trickiest question that we had. So we will solve it in a while. Let me just go to this question number 19. What is the time complexity of this following loop? You are going to run it log of I square times, right? Which means 2 log I time. Okay, is this okay to everyone? Log of n, generally it is log of n, but since it is I square, that is why log of I square. Now tell me what is the answer. So for I equal to 1, log of I square times log of 1 square time. For I equal to 2, log of 2 square times. For I equal to 2 cube, log of 2 cube square, right? 2 cube square times. Yes. Why log of I square? Because if it is n, then this is log n. If j equal to j into 2. But since it is I square, that's why you are going to run log of I square times. Okay. Which means for I equal to 1, log of 1 square, for I equal to 2, log of 2 square, for I equal to 3, log of, so for I equal to 2 square, this will be 2 square. Log of 2 square times I equal to 2 cube, log of 2 cube square times. Actually, this square doesn't matter. Maybe I can simplify this as 2 log I. Okay. So instead of writing log I square everywhere, let me write it 2 log I. Okay. And then finally, I will be 2 power k. Then it will be 2 into log 2 power k. Okay. So which is n? If you add all of this, then what you will be getting? Can you try this? So 2 you can ignore. So log 1 plus log 2, which means it is multiplication like that. I hope that is fine to everyone. Which is just 2 power log of 2 power 1 plus 2 plus till k, which is k square, right? This is multiplication. This is not addition. This is a multiplication. So I mean, this is not the GP. I mean, this is not the summation of the GP. Okay, this is you are multiplying. So you need to add the powers. Is this okay to everyone? So now you can take this outside, maybe if you want, which is 1 plus 2 plus till k, and this is just k square. So I think the k square is the answer. And what is k? K is log n. So log n square should be the answer. Okay. Yeah, it was a good question. Let me know if you have any doubt here. If you just solve this by yourself, then you will be probably getting more idea. Let's just solve this question. What is the time complexity of the following loop? So this is log n times. Since it is independent, let's not worry about it. So let's just solve these two, right? J equal to n, and this will run log n time, right? This is going to run n minus j divided by 2 times. Okay, that's interesting. So let's just do this. For j equal to n, how many times this will run? 1 time, 0 time, doesn't matter. For j equal to n by 2, this is going to run. Let's not worry about this by 2, okay? I'm just writing n by j, n minus j. This is going to run n minus n by 2. For j equal to n by 2 square, this is going to run n minus n by 2 square. Similarly, for j equal to n upon 2 power k, let's suppose this is 1 ultimately, which is n minus n upon 2 power k. How many terms are these? K terms, right? Are you getting my point? Should I solve this again? See, j will, let's just forget about it. Okay, let's first forget about it. And then you need to run for j. For j equal to n, what is happening? For j equal to n, this will run n minus j times. This is always going to run n minus j times. So 0 time or 1 time does not matter. For j equal to, then j will be n by 2. This is going to run n minus j times. So n minus n by 2 times. N by 2 square, n minus n by 2 square, like that, right? Okay. Now you need to add all of this. So it is, okay, you can say it is n minus n or something like that. So it is basically, these are the n, these are the k terms. So I think n into k, this summation, the first term summation will be n into k, right? Minus this is n plus n by 2 plus n by 2 square plus n by 2 power k. Since it is a decreasing GP, I think you can just ignore all of this. This is just n. So it is nk minus n. And ultimately, this is just nk. And k value is log n, so n log n. Right? And then this is also log n. So n log n square, I think that's the answer. Yeah, n log n square. So that was a good question, right? Have you understood, or should I solve it again? Let me know. You can just tell me very frankly. See, what we first did, we first ignored this, right? We first ignored this. And then I'm just going to say that this loop is going to run n minus j by 2 times, because n minus j, and you're each time you're adding by 2, right? So n minus j by 2, or let's just say n minus j times. Okay. I mean, this by 2 won't matter. So let's just say n minus j times. So you are going to run n minus j times. This loop is going to run n minus j times. So which is the first thing. Okay. And then for every j, we need to calculate what is happening. So we said j will be running from n. Just a second. Yeah, j will be running from n to 1. So from n, which means n minus j times. So n minus n times. J equal to n by 2. Then it is going to run n minus n by 2 times. J equal to n by 2 square. N minus n by 2 square times. And then finally j will be j will be 0 or 1 or whatever. So again, I'm whenever it is 2, then always take 2 power k. So which is just 1. Okay. So which is just 1. Then it is n minus n upon 2 power k times. That's all. Now you need to add all of this. Okay. So if you add the first term, it will be n into the number of terms. Since the number of terms are k. Why? Because this is 2 power 1, 2 power 2, 2 power 3. So that's why, I mean, these are the 2 power k. So number of terms are k. So here the number of terms equal to k, or k plus 1 does not matter. So let's just take it k. So n into the number of terms, k minus this. If you take minus common, then this will be the summation. Okay. Then n into, or maybe let me just directly sum it. Then it is n plus n by 2 plus n by 2 square, like that, right? N by 2 power k. Since it is decreasing GP, you can just say it is n. This is n. Since it is decreasing GP, the whole thing is just n. And then finally you can say it is nk minus n. Since this I mean, this n is just less significant rather than nk, so you can just say it is nk, or maybe you can say n into k minus 1, and this is just 1, so nk only. Okay. I mean, you can just ignore this n here, or after taking the common, you can ignore anywhere. So basically this is nk. So final answer is nk. But can you just say that nk is the answer? I mean, later we will multiply the log n, that is okay. But can you say nk is the answer? Can you answer in terms of k? No, right? You need to put the k in terms of n. So it is n log n. N log n. Yes. And then you need to multiply by the log n. Yes, you need to multiply by the log n. So basically this is just answer for these 2 loops. Okay. Then you multiply by the log n log n square will be the answer, final answer, right? So this was also a good question, I think. So overall, this practice set was designed in such a way that you get the good idea about the loop time complexity. Okay. So I think we have covered many variations. Yes, there is one good question that is pending. So let me know if there is any other doubt other than this. Let's just solve this question. Do you want to spend 2 minutes just to solve this question? Maybe I can proceed, and then I will stop after seeing that what it is doing. Okay. Okay. Let me just see what it is doing, then I will stop in a while. Yes. So basically it is going to run n times. This is I square times. Okay. The interesting part here is that this is going to run j time. That is okay. Interesting part here is that if j is a multiple of I, then only you are going to do this, right? So basically I equal to 1 for every iteration, right? I mean, this is just one iteration. So for I equal to 1, this is going to run 1 square times, and this is going to run based on whether j divides I or not. Okay, so let me just put a blank here. For I equal to 2, this is going to run 2 square times, and then this is the innermost loop. So basically the final answer will be whatever. Let's suppose this is x. I mean, then if this is x, then I will multiplying these two. Okay, if this is x, I will multiplying these two. So basically I don't know what is this, right? I mean, if j is a multiple of I, then I'm going to run this j times. Okay. So for how many times this condition is true? Let's suppose let's forget about this I and all. Let's just focus on this inner for loop. Okay. For how many times this condition is true? J value will be 0, then 1, then 2, and like that, right? So whatever is the value of I, basically, whenever J value is I, then it is true. If J is I, then it is true. Whenever J is 2I, then also it is true. Whenever J is 3I, then also it is true. Whenever 4I, whenever till the moment J is I into I. So basically it is going to true I times. This is going to be true I times, right? So this if condition is going to be true I times. Why? Because for j equal to I, it will be true. For j equal to 2I, for j equal to 3I, till the moment j is I square, right? Till the moment j is I square. So I can say this inner loop, this if condition, at least I can say it is going to be true I times. That's the one observation that we can make, right? Okay. So I can say that this is going to be true I times. And this is going to run j times. Okay. So you can say for I equal to 1, for I equal to 1, this is going to run I square time, that is for sure. This is going to run 1 square times, but out of those 1 square, or maybe for any I equal to k, this is going to run k square times, but out of those k square, okay, I mean, okay, so basically, is this clear that this is going to run k square times? For I equal to k, this is going to run k square times, right? Now let me divide this k square into two parts. I mean, let me just say that k square is just nothing but k square, okay, minus k plus k. Is this okay? I mean, just rewriting this k square. मतलब मैं क्या बोल रहा हूँ कि this is going to run k square times for I equal to k, but out of those k square, k times will be such that this is also true, है ना? And k square minus k times this is not true, which means that for I equal to k, that this the total time complexity of this whole thing is basically k square minus k times just doing nothing, matlab order of 1, and k times it is doing this j work, right? K times j work. Okay, so here also I need to think about it. So basically, like I can overall say that j into k. Okay, we will figure out that how to formulate this, all of this. So overall I can say for I equal to k square minus k times I'm going to do just constant operations, but k times I'm going to run this j. Is this okay to everyone? Okay, now let's just see if we can figure out this j also. Okay, if I is k, then j value it is okay, k times it is going to run, j is also not constant, right? I mean, j value will be 1 and then 2. So okay, it's that much tricky. Okay, or maybe I'm making it a little complex, but anyway. So is this okay that k square minus k times it is going to do constant times, but k times it is going to do something, right? So let me write this k times also in the different parts. Okay, ultimately मतलब k times इसको चलना है, right? K times it will run. So this is k summations. And in k times also, like it will, j value will be k, 2k, 3k. If I is k, okay, I'm taking some fixed I, which is k, then k into k. So see, k square minus k times, just one operation. K times, in k times also, okay, in just k times, the first time, within the k time I'm talking, the first time j is k, second time j is 2k, third time j is 3k, right? Is this fine? Whatever I'm saying, k square minus k times constant, k times it is going to run this loop. But inside the k time, first time j is k, second time j is 2k, third time j is 3k. So last time j is k square or k into k. Now this loop is going to run j times. So which means it is going to run k times because j is k, then 2k, then 3k, then k square. K into k basically, right? K into k. So you just take k common, it will be 1 plus 2 plus 3 till k. It is k cube, right? K cube. So for I equal to k, you can say k square minus k times just constant operation. Remaining k times, it is total going to do k cube operations, right? For I equal to k. And which means asymptotically for I equal to k, this is going to run asymptotically how much time? The inner loops are going to run k cube plus this. So asymptotically, you can say it is just k cube. For I equal to k, it is going to run k cube times, right? The inner loop, all of this, which means now I can do this, right? For I equal to 1, 1 cube, for I equal to 2, 2 cube, and for I equal to 3, 3 cube, like that. So if you, this is k cube. If you add all of this, then what is the answer? This is basically, you can say this is 1 cube plus 2 cube plus 3 cube. I think this will be in the order of k4. Okay. Sorry, k is just n because I will be running n times. So this is n cube. This is in order of theta of n power 4. Yeah, that is the answer. So maybe I can just tell you once more that what is happening here. Let me see that how they have solved it. If the condition j is a multiple of I, this will happen. That is okay. I into I times 0 to. So the third for loop run only I times. Yeah, this is going to run only I times. They are saying this run n times, this run n square times. I think this is, let me just put it like that. This run n time, this run n square time. So n square into n cube times basically. Okay, this is going to run. Just a second. Order of n into order of n. Okay, they yeah, actually, I mean, this is also okay, but this will little bit confuse you. So maybe you can understand like that only. So let me know if that explanation is okay to everyone. Should I repeat it? Okay. See what is happening. Maybe I can just copy this. Let's just talk about for I equal to k, for any random I equal to k, how many times this loop is running. Okay. Is this objective clear? For I equal to k, let me just see how many times it is running. So I'm fixing the I. Okay, I value is k. I'm not saying I equal to 1 or I equal to 2. I will do this later. So let's just see for I equal to k how many times this is running. Okay, I is k, so which means k square. Acha, different variable I can choose. Okay, maybe t. Oh, m. Okay, let's just take m. So this is m square. So this loop. Okay, so I'm just taking the fixed I. So let's not worry about it. Okay. So let's say I is m. So this is m square. Okay, let's say this is m square. Okay. Now this is true m times, isn't it? Is this okay to everyone? This is true m times. Is this okay? This is true whenever j divides I. Okay. So since I value is m, whenever j divides m or something. So basically, let me just explain you with I first. So what is happening? That j value will be 0, then j value will be 1, then it is 2, then it is 3, and then ultimately it has to be I square, right? That's what it is happening. Now somewhere j value will be I, right? Somewhere j value will be I, somewhere j value will be 2i, somewhere 3i, somewhere 4i, and then ultimately I into I. So this is true whenever j is a multiple of I. So which means whenever j is I or 2i or 3i or 4i or 5i or I into I. So how many terms are these? 1 into I, 1, 2, 3, 4. I mean, fourth term. So total ith term. I mean, total I terms are there. So if it is I, then this condition is true I times. Okay. If I'm taking I values as m, then this condition is true m times. This is one thing that you need to understand. Let me know if that is clear. That will be true if I value is m. That will be true whenever j is 1, sorry, j is m, or maybe j is 0, whenever j is m, whenever j is 2m, whenever j is 3m, like that, right? It will be true with the multiple of m. And that will come m times in if you are talking till m square. Okay. If you talk, if let's suppose this is m cube or something, then m square times, like that. Okay. Anyway, so basically this is true m times. That is one thing. So this is going to run m times. This is what I'm saying. Now I'm picking I value is m. Okay. So total this loop is going to run how many times? M square times. Suppose this is just constant. This is constant. Then what is the answer? M square. But since this is not constant, they are having something. So basically, I'm just saying within this m square, I'm just saying m square minus m times this if condition is false. M times if condition is true. Is this okay to everyone? I mean, this is going to run m square times, but out of those m square minus m times if condition will be false, but only m times it will be 2. Okay. So now if it is false, then I'm not going to execute all of this. I'm just doing the constant operation. So m square minus m into 1. I'm not doing anything, right? Plus, if it is true, then I'm doing something. Okay. Now let's just see what I'm doing. If it is true, then it will be true for j equal to 1, j equal to j equal to 0, j equal to m, j equal to 2m, and j equal to m into m. I mean, for the multiple of m, right? It will be true m times. See, if it is false, I'm not doing anything. If it is true, then I'm doing something. Okay. It will be true when j is 0. It will be true when j is 1. It will be true when, okay, when, I'm saying when. So it will be true when j is 0, when j is 1, when j is 2m, like that. If j is 0, then it is true. If j is m, it is true. If it is true, then it is going to run j times. Right? J times. So which means if it is true, okay, so Twinkle is saying कि अब समझ में आ गया. So if it is true for then it is going to run j times. Now when it is true at j equal to 0, so 0 times you are going to run this innermost loop. If it is true, then you are going to run j times, right? J times. Now at j equal to m also it is true. So basically what is happening, it is true j times, it is ultimately this is true m times. Now I'm basically breaking this m, okay, because it is behaving differently. So I'm saying that, okay, this is first time whenever it is true, whatever I'm doing, second time whenever it is true, third time whenever it's true, fourth time, and till m times, right? So basically मैंने क्या किया, m square times it is going to run, m square minus m is very simple. M is, I'm taking m separately. इस m को भी I'm just dividing one by one, one, total m terms. These are the total m terms. Okay, total m terms. I need to see that every time what is happening. Okay, I need to see every time what is happening. Now for j equal to 0, it is going, every time it is going to run j times. So it is going to run 0 times. Then for j equal to m, because at j equal to m it will be true, m times, then 2m times, then 3m times, then m into m times. So basically total time complexity is m square minus m plus all of this. Okay, so which means that this is m square minus m plus, if you just add all of this, then what will the answer? M you can take common. If you take m common, this is 1 plus 2 plus till m, which is m square, right? So m square into m, it is m cube. So finally I can say m cube times. So this is running m cube times. Okay, which means for I equal to m, you are running m cube times. Okay, now since the I value is going from 1 to n, so this loop is running m cube times. That is one thing. Now for I equal to 1, you are going to run 1 cube time. For I equal to 2, you are going to run 2 cube times. For I equal to 3, you are going to run 3 cube times. Similarly, for I equal to m, you are going to run m cube times. Now you need to add all of this. Okay, you need to add all of this. So this is not the GP, neither this is AP. How to add all of this? Can anyone tell me how to sum this number? Which means, I mean, in general, I am saying 1 cube plus 2 cube plus 3. Okay. See, you don't need to apply the formula and all. You can just integrate it. Integration is also fine. Okay. So do you remember in calculus we did one thing, like we told like this integration is bounded by the summation. थोड़ा adjust करना पड़ता है +1 -1, right? If it is increasing, if it is monotonically increasing. Do you remember there was one question in the calculus we did? Anyone remember that? So we took, I think, half an hour, more than half an hour time. There was one graph. It was a graph. I told, okay, if you are taking the sum, if you are going from this side, then this inequality was coming. If you are going from this side, this inequality was coming. Anyone remember? At least, like, not the exact thing, but at least some vague thing. So basically, if it is a monotonically increasing function, you can integrate. Okay, because if you remember, that function was increasing. We have proved that the function is increasing, you can integrate. If you integrate it, then also it is fine. Okay, I mean, you don't need to for the asymptotic notations, you don't need to do the exact thing. The integration is also fine. So integrate this I cube or x cube. So x cube integration is, I think, I power 4 by 4, right? I think something like that, right? So you can say ultimately if you integrate this will be yeah, so this will be m, like you need to put the limit 1 to m. So this is m power 4 minus plus, let's not worry about it. Okay, so finally it is, sorry, this is n, this is n. I mean, I is running till n times. Too much of concepts we have applied here, but anyway, integrate कर लिया करो, कोई दिक्कत नहीं है. In asymptotic notations, the summation and integrate both are same. Okay, so you can integrate in asymptotic notations. If you are having any confusion, you can integrate. So n power 4 is the final answer here. Because in asymptotic, actually, these functions are always increasing. So you can replace the summation by the integration. Okay, so you just do it one more time by your own. I think that's the best thing I can do in this video, because I keep on repeating the same thing. Otherwise, you can just watch the video again. Okay, this is also one thing that you can do. Cool. So I think we can stop here. Okay. Let me know if you have understood this. There is any confusion, you can let me know. Yes. Okay. You can unmute yourself. Okay. Everyone else is done, right? Cool. So thank you, everyone. We will be meeting in the next video. Yeah. Thank you so much.